In today's video, we are going to discuss about the Nash equilibrium with unit constant cost in the Cournot model. So we have to find out the Nash equilibrium in the Cournot model, and we will assume that there is a unit constant cost in the market, and we will also find out what are the necessary conditions or what are the necessary and sufficient assumptions for the existence of the equilibrium. So the question will be, mainly our question in this video will be finding the Nash equilibrium in the Cournot model and here we are going to do about we are going to do with the two Celler Cournot model and not the n Celler Cournot model. So we are going to find the Nash equilibrium with in the Cournot model with constant cost. And we are also going to know about the necessary conditions that are necessary and sufficient conditions which are important for the Nash equilibrium or important for the Nash equilibrium to hold. So we are also going to look about the necessary and sufficient conditions for the Cournot Nash equilibrium. So for this, at first we will set the model. For setting the model or for setting up the model, we have two players here. The two players are basically the farms. Two farms are our two players who are going to play in the game. So two farms are our players, farm 1 and farm 2. These are the two players that we have in our model. So F1 is the farm 1 and F2 is the farm 2, and these two are the two players in our Cournot Nash equilibrium in our Cournot model. What are the strategies that the farm 1 and farm 2 have? Now if we go with the if we want to know the strategies of the players, now the quantities of, so basically the strategies are basically the quantities that each farm is choosing to produce. So suppose farm 1 is choosing to produce Q1 amount of output and farm 2 is choosing to produce Q2 amount of output. So these are the strategies of both these farms. So we have assumed the player names and we have assumed the strategies also of the each player. Now what are the payoffs for the each farm or each player? The payoffs for each farm or each player will be the profits that they are making. So suppose farm 1 is making pi 1 profit and farm 2 is making pi 2 profit. So these are the profit that each farm receives based on their chosen quantities and market price demanded by aggregate quantity. So basically this profit is based on their chosen quantity, that means how much they are choosing to produce, and the price of the product. That is obviously the price will be determined by the product demanded by the aggregate quantity of the market. So these are the payoffs that we have. Pi 1 is the payoff for farm 1 and pi 2 is the payoff of farm 2. Pi 1 is depending upon the quantity of the farm 1 and the price of the product, and pi 2 is being determined by Q2 and P2. Q2 is the amount of production by farm 2 and P2 is the price of the product of the farm 2. Now if we want to set up the game, then how can we set up the game? Now we will look into that fact. Now for Nash equilibrium, we have to assume, at first we have to assume that we have to find out, here we are going to find the Nash equilibrium. Now for Nash equilibrium we have to, at first we want to know what is the total amount produced in the market. So suppose Q is the total amount produced in the market. So Q will be nothing but the sum of Q1 and Q2. Here Q1 and Q2 are nothing but the amount produced by farm 1 and amount produced by farm 2. So this is the total amount of production in the entire market, or total amount of output present in the entire market. Now price is a function of quantity, we know, and price is basically a linear function of quantity, and it is a negative function of quantity. As quantity increases, price will fall. So a minus bq, if we take a linear relationship, or if we take a linear function where we represent price as a function of quantity, then this type of function will be represented. Here a and b are constant and a and b are greater than 0. Constant, or basically we can say that a and b are positive constants. So I can write it as a minus, in place of b. In place of b I can in place of q, capital Q, I can put q1 plus q2. So it will be a minus q1 plus q2. Now what will be the profit for farm 1? If I want to know what will be the profit for farm 1, then I can write, suppose for farm 1, I want to determine the profit of farm 1. So for farm 1, the profit pi 1 equals to, what is profit? We all know profit is nothing but it is the revenue that you have generated from your business or from your product and the cost of your product. Here we have assumed that we are taking a constant cost C. C is our constant cost, and it will be a cost for both of the farms, not for the farm 1 only but for the farm 2 as well. Now if we want to know the value of revenue for farm 1, then what will be the value of revenue for farm 1? So revenue is nothing but, we all know revenue is price into quantity, right? Price into quantity, and cost is a constant cost. And what will be the total cost? Cost is nothing but the cost into quantity will be your total cost. So how much you actually cost into quantity is actually your total cost, that how much you have actually spent on your production. So cost into quantity. Now if I want to put it into equation, what is price? Price is the equation that we have represented here in the earlier slide. This is the equation of price, P of Q. So if I write in place of P, if I write in place of price, if I write P of Q, okay, and into multiplied by quantity. So farm 1 is producing Q1 amount of quantity, so in place of quantity I can write Q1. Similarly cost is C, constant cost, we are assuming that constant cost is C. Constant cost in the market is C, and it is same for both the farms, for farm 1 as well as for farm 2. And Q is the amount of cost. Q is nothing but the quantity produced by farm 1, and farm 1 is producing Q1 amount of quantity, so I can write Q1 here. If I take the Q1 common out of it, so it will now become P of Q, P of capital Q, which is the function of linear demand curve or linear demand function, and I am taking the Q1 common out of it, so P of Q minus C into Q1. Now we all know this P of Q was written as a linear demand function, and it was written as A minus B into Q1 plus Q2, as you can see it from here. So if I put it into the equation, that if I put A minus B into Q1 plus Q2 and minus C into this Q1, then we have actually derived the profit of the farm 1. Similarly, we can, in this same methodology, we can find out the profit for farm 2. So profit for farm 2 will be profit for farm 2. If I want to write profit of farm 2, I don't want to derive it because it is just will be in the same way as it was in the, this was the profit for the farm 1, pi 1. Now profit for the farm 2, pi 2 will be A minus B Q1 plus Q2 minus C into Q2. It will be just in the same way as you have done the profit, or as you have derived the profit of farm 1. So we have derived both the profit of farm 1 as well as of farm 2. Now we want to find out the best response function for the farm 1 and farm 2. So let us write the best response function for the farm 1 and farm 2. Best response function. Now for finding out the best response function, we have to understand that each farm actually maximizes its profit by choosing the amount of Q1 and Q2. I mean to say, suppose farm 1 actually chooses that how much of their product that they want to produce. Suppose they want to produce 20 units of their products. So 20 units is the Q1, and if it maximizes their profit, then they will be very much satisfied with it. But if farm 1 feels, or if the calculations are actually showing that farm 1 will maximize its profit at 45 units of output, then obviously farm 1 will produce 45 units of output. Then that will be the Q1. So each farm maximizes its profit by choosing the amount of Q1 and Q2. Q1 will be chosen by farm 1 and Q2 will be chosen by farm 2. Now for farm 1, I want to see what will be the profit maximizing point, or what will be the profit maximizing output for farm 1. So for that we have to derive, we have to at first write the profit function, which was A minus, as you can see from the earlier slide also, it is A minus B into Q1 plus Q2 into Q1 into Q2 minus C into Q1. Now we want to do the differentiation of this equation with respect to Q1. We all know that there are two conditions of profit maximization. One condition is that the first order derivative will be equal to 0. So we are going to set this first order derivative equal to 0. And the second condition is that the second order condition is negative. We don't have to prove the second order condition here. The first order condition, which is equal to 0, is sufficient for our finding out the value of Q1. So if we take the first order condition equal to 0, let me find out the value at first. What will, if we differentiate this equation with respect to Q1, then at first it is better if you break this equation at first and then do the differentiation, because then that will be much more easier for you to understand. So if I multiply this Q1 with all of these terms, so it will become A Q1 minus B Q1 and Q1 multiplied again, so B Q1 square. Similarly it becomes minus B Q1 and Q2, so Q1 into Q2, and it becomes minus CQ1. Now it will be very much easier for you to do the derivative. So if I find out the derivative of this function with respect to the quantity produced by farm 1, that is Q1, so it will be A minus 2BQ1 minus BQ2 minus C, and we will set up it as equals to 0. It is a very basic differentiation. I hope you can understand it. So by solving this equation we can get the values of Q, or we can get the value of Q. What will be the value of Q here, or what will be the value of Q on here? So value of Q1 will be represented as the value of Q2. So here value of Q1 is represented, if you can solve it you can easily find out that value of Q1 will be A minus C minus B Q2 divided by 2B. Similarly, if we do the derivative of the profit of farm 2 with respect to Q2, that is the quantity produced by farm 2, then we will get A minus BQ1 minus 2B Q2 minus C equals to 0. Similarly, from this you can find out the value of Q2, which will be represented as the value of Q1. So q2 here will be a minus c minus bq on by 2b. So we have found out the value of q1 and q2. Now let me give it as equation 1 and equation 2. I want to substitute the value of q1 in equation 2. Here in the q1, in the value of q1, I want to put this value of a minus c minus bq2 by 2b. So if I do this, if I put the equation number 1, and within equation number 1 I want to put the value of q2, so a minus c minus b, a minus c minus bq1 divided by 2b, and I multiply it with by 2b. By solving this equation you will find a value that will be equivalent to, if I really want to solve it, then it is, suppose it is a by 2b minus c by 2b minus b and b by 2b, and this is b by 2b, and multiplied by a minus c minus, I think more space is required here, b by 2b multiplied by a minus c minus bq1 by 2b. Now this will be a minus c by 2b, just these two parts are a minus c by 2b if you calculate, and this part b and b are getting opted out, so we have only minus 1 by 2 remaining, and from this part we can get the value of a minus c minus bq1 by 2b. So after solving this equation, I feel if we this can be multiplied with 1, so let me write it as, I feel little bit more space was required here, 2b, so little bit more space is required here, but if I write it, then it will be a minus c minus bq1 by 2b, that will be in the numerator part, and it will be multiplied with 1. So if I simplify it again, and I can write a minus c by 2b, and with it if we write a minus half, and minus half getting, and with this 1 I have to multiply this a minus c, maybe yes, a minus c minus bq1 by 2b. Now if you multiply with this, then it will be a minus c by 2b minus a minus c minus bq1 by 2b divided by 2. Divided by 2 means nothing but multiplied by 1 by 2. Okay, so it will be divided by 2 means I can write multiplied by 1 by 2. Actually it was in this form, right, like this, so it is nothing but it is 2b divided by 2, so divided by 2 can be written as multiplied by 1 by 2. Multiplied by 1 by 2 means it becomes 1 by 2 2 multiplied with 2b, so it becomes 4b. If we do the calculation here, so 4b and 2b LCM will be 4b. From here we get 2a minus 2c minus a minus sorry, not minus, plus c plus bq1. So from this is the value of I can find out that this is the value of it is 2a minus a will be a, 2c minus 2c plus c will be minus c. So a minus c plus bq1 will be, and divided by 2b, divided by 4b, and this is equivalent to our value which was q1. Q1 was the value that we are trying to find out, so it is equivalent to q1. Now just cross multiplying this, we get 4b q1 equals to a minus c plus bq1, and if we take this bq1 on the left hand side, then it becomes 3bq1 and it is a minus c, and just taking this 3b in the left hand side, we get the value of q1 as a minus c by 3b. In the same way, if you calculate the value of q2, you will also find out that q2 will be also a minus c by 3b. I haven't jumped any step in the previous equation. I really wanted to show. I may have written all this a minus c by 3b directly, but I wanted to show the calculation so that it becomes easier. So the Cournot-Nash equilibrium quantities that we are trying to search, or that we are trying to find out here, this is the condition. We are trying to find out this Cournot-Nash equilibrium condition. Now Cournot-Nash equilibrium condition, the Cournot-Nash equilibrium condition is, or Nash equilibrium quantities that we are trying to find out. We are trying to find out the Cournot-Nash equilibrium quantities in which both the firms are agreed to produce. So Cournot-Nash equilibrium quantities are nothing but q1 star equals to q2 star equals to a minus c by 3b, a minus c by 3b. So now the conditions, the second part of the question, that what are the necessary and sufficient conditions for this Cournot-Nash equilibrium. So for finding out this Cournot-Nash equilibrium, the necessary and sufficient conditions are very much important in this respect. The first condition is that, look at this value, this is a minus c by 3b. The quantities that we have derived is a minus c by 3b, and if by anyhow c is greater than a, if by anyhow c is greater than a, then the quantity will become negative. Okay, if c is greater than a, suppose c is 10 and a is 8, so a minus c will be nothing but minus 2, so it will be minus 2 by 3b. So whatever is the value, q1 will be negative, the quantity will be negative, q1 star q2 star will be negative. So we need that c is greater than a, it should not be hold. The condition, the first necessary condition will be that a should be greater than c, and a should be greater than c. That is the first necessary condition that we require. Now what is a? If you can go into the demand function that you have written here, a was basically the intercept of the demand function. So the intercept of the demand curve should be greater than the cost, constant cost. So the intercept of the demand curve, should be greater than the cost of the, or you may say constant cost of production. Okay, so this is the first condition, first necessary condition for this Cournot-Nash equilibrium, and quantity should not be negative. And second condition is, this is a very interesting condition, and the second condition is that the quantity should be non-negative. The quantity should be non-negative if this holds, if this condition holds, that a is positive, and if a greater than c, then the quantities will not be negative, the quantities will be positive. So this is a very important condition. And the second important condition is a should be positive. That means the demand intercept, the intercept of the demand curve or demand function, a should be positive. Otherwise obviously this value will be turned, if a is negative, then we may not reach to this conclusion. A can't be greater than c then, because there is a cost is already, we have, we want cost should be lower than a, but if a is negative, then if cost is lower, then cost will be much more negative. So in that case we can't find out the Nash equilibrium, because cost can't be negative. So a should be positive, that is the demand intercept, the intercept of the demand function should be positive. So this is it for the video. These are the two conditions. I hope you have understood the conditions that are necessary for the Cournot-Nash equilibrium.